Shaji. I'm here to present my seminar on the topic VLSI design and electronic circuit synthesis under the guidance of Mr. Anto Manuel, Assistant Professor of PC Department. Moving on to the slide. These are the contents which are involved in my presentation. In the field of electronics and semiconductor technology, VLSI design and electronic circuit synthesis are the major areas. This field involves designing and synthesizing complex integrated circuits. VLSI design, it is a process of creating integrated circuits by combining thousands or even millions of transistors in a single chip. It enables to develop highly efficient and powerful electronic devices. In electronic circuit synthesis, it is a subset of VLSI design which focus on automatically generating electronic circuits, and the process involves using computer-aided design tools and algorithms, and which optimizes the parameters like speed, power consumption, and area of circuits. Moreover, electronic circuit incorporates a CPU, RAM, ROM, and other software on a single PCBA. At VLSI, add all these components into a single chip. Moving on to the history part. At 1947, the first transistor John Buttin and Walter Buttin has invented, and it was the first functioning point contact transistor at Bell Labs. And in 1958, Jack Kilby developed the first IC. It was a major milestone in electronic and computing. It marked a revolutionary departure from the traditional way of constructing electronic circuits, which involved connecting individual elements in the board. And in 1959, Devan Kang and Martini Mettella developed or invented MOSFET. MOSFET helps to miniaturization of electronic components, and its power consumption is low and highly reliable and compatibility with integrated circuit. And in 1963, Frank Van Lis invented logic gate with MOSFET. And in 1965, Mr. Gordon Murray graphing the quantity of the semiconductor. And he developed the Murray's law. And in 1970s, NMOS technology came into picture. And in 1971, the first microprocessor 4004 was developed by Tech Hope. And in 1980s, VLSI tab introduced, and also a 32-bit microprocessor contains 275,000 transistors. And in 90s, 32-bit microprocessor which contains about 3,100,000 transistors. And in 2000s, a 64-bit microprocessor and which contains about 592 million transistors. And in 2010s, the count of the transistor again increased and it went up to 8 billion transistor. And in 2020s, the transistor amount was up to 54 billion transistors. It is the images of the first linear circuit and the first transistor. The 4004 first microprocessor image and Intel Pentium 4 image. Murray's law. At 1965, Mr. Gordon Murray observed that graphing the quantity of the semiconductor which can be fabricated in the most economical way on a chip, which gave results which were in the favor of advancing transistor technology. The law states that number of transistors in an IC doubles about every 18 months, and this law is called Murray's law. Moving on to the design flow. These are the general steps involved in the design flow. The first one is system specification, architecture design, functional design, logic design, circuit design, physical design, fabrication, and packaging and testing. In the system specification, main objective of the desired system product is written, and also estimated cost of the product and how it will perform, and also the architecture of the desired system, and also how the system will communicate with the external world is also determined in this step, and the specifications are provided by users and clients. And the next step is architectural design. Architecture of the desired system must meet the specification of the desired system. Here the architecture of the desired system is decided and the layout of the same is also determined. Architecture design is the integration of the analog and mixed signal blocks, and also its power requirements and also its memory management. And functional design, it consists of the refining the system specification of the desired design in order to design this functional behavior of the desired system. The main objective is to generate a high performance architecture design within the cost requirements versus by the specification. And next step is logic design. It is a structure of desired system. Desired design is added to the behavior representation of the desired design. The main specification involved in the logic design are logic minimization, performance, enhancement, and stability. Logic design must consider the problems associated with test vector generation, error detection, and correction. And next step is circuit design. The logic blocks are replaced by the electronic circuits, includes transistor, capacitor, and resistor. Circuit simulation is done at this stage to verify the timing behavior of the desired system. SpaceWise is a well-known program for the circuit simulation. Physical design. In this step, all components are placed and interconnected. The design rules must be followed, otherwise errors such as short circuit, open channels, etc. may result. And the thoroughness of the chip is also controlled at the physical design. Fabrication. After the actual layout and the verification of desired design, the design is sent for manufacturing, and this process is called tape out. And for the generation of the data for manufacturing is called streaming out. And the last step is packaging and testing. After fabrication of the desired design, the functional chips are packed, and these package types include dual inline package, pin grid array, ball grid array, and etc. After a die is positioned in the package cavity, its pins are connected to the pins of the package, and the package of desired design is then sealed and it is sent to the end user. Applications of the VLSI design. Some of the applications of the VLSI design, we use VLSI in computers and mobile devices. The main purpose of using the VLSI in the computer and mobile devices is to improve its processing power, reduce their size, improve their functionality and battery life. And the medical electronics we normally use to improve the diagnostic accuracy and the patient care. And the automotive electronics, we use VLSI to improve the safety and performance. And we also use VLSI technology in aerospace. The main objective or main aim in this area of usage is to improve the communication and navigation systems. And VLSI help to measure the road height and estimated length of the outside road in the GPS in the car. Some of the software involved in the VLSI design are EDA software, layout editor, verification tools, and fabrication tools. EDA software is to automate design and simulation of the electronic circuits. Some of the examples of video software are the synopsis and cadence design systems. And in layout editor, we used this tool to design the physical layout. Examples are the link and simulator. And the verification tool to ensure design to and we use verification tool to ensure whether the design meets all the requirements and specifications provided by the client or end users. And examples are calibrate design solution. And the fabrication tools are used to create physical version of the VLSI design. And one of the problems faced by the people are um, we cannot install or cannot possess this software without any authorization or without any valid authentication, because some of these tools are developed by the prominent companies like Synopsys and Cadence. uh, we need special permission or security. All other things are needed for the installation and usage of these tools. Current trends. Some of the current trends of the VLSI are neuroformic computing. We normally use neuroformic computing to develop more effective and intelligent computer systems. And in non-volatile memory, uh, when the power get off, the memory does not get erased. And for getting a high capacity and low power memory technologies, like in resistive random access memory and phase change memory, we use VLSI for such a capability, for getting such a capability. And reconfigurable computing means the system are highly flexible and efficient computer system. This criteria can be achieved by the industry's advancement. Field programmable gate arrays, which dynamically change to carry out various functions. All these are possible by the usage of VLSI. Biodegradable electronics. The creation of biodegradable parts and the circuits for use in the medical implants and other applications. Biodegradable electronics reduces the e-waste. And other current trends are neuroformic sensors, which enable more effective and intelligent sensing in robotics and other applications. And in memory computing, faster and more effective data processing is made possible by in-memory computing. AI chips are specialized processors created to carry out machine learning tasks like speech and picture recognition. Recent developments in the VLSI have produced more effective and potent AI circulation. And in hardware security, it entails design and deployment of the secure and reliable hardware solutions. Advanced packaging is also a current trend of VLSI, which enables more effective and power efficient electronic systems. Some of the future scopes of VLSI are artificial intelligence and Internet of Things are driving for more powerful and energy efficient chips. All these more powerful and energy efficient chips are made possible by the VLSI technology. And of course, in the development of 5G technology, VLSI technology plays a very important role. And machine learning accelerators, advanced process technologies, quantum computing, bioinformatics, and biomedical applications, these are the future scopes of VLSI technology. Some of the future challenges faced by the VLSI technology are very slow implementation in the coming decade, challenge over power consumption, interconnected transistor scaling, platform integration. What is mean this? I meant from I uh, what what I meant is that in Moore's law implementation can indicates is that the size of transistor could someday reach to an extent that we cannot reduce further as we cannot reduce size of anything to less than an atom. Another challenge faced by the VLSI is the power consumption. Um, That means the transistor does not consume much power. But as we look in the view of VLSI, VLSI uses thousand or even millions of transistors, which at addition consumes a significant amount of power. And interconnect and transistor scaling is another challenge faced by the VLSI, and that needs to be improved. And platform integration is another challenge faced by the VLSI. At the stage level, outside transport recurrence have not stayed up with processor recurrence. Electronic circuit synthesis. The key aspect of electronic synthesis are high-level synthesis, converting a behavioral description of the circuit into a RTL description. A logic synthesis is the automatically generated gate level or transistor level circuit from RTL descriptions. And in the case of physical synthesis, optimizing the placement and routing of the component are need to meet area and performance constraints. And optimization is the iteratively refining the design to improve its performance and efficiency. And some of the RTL design tools are synthesis tools, simulation tools, and verification tools. In synthesis tools, the RTL code is the input, and we produce a gate level synthesis as the output. And the simulation tool, it allows the designer to test the RTL design using the input stimuli and observe the output response to ensure that chip behaves as intended. And in verification tool, it is to check the design correctness and completeness and also include formal specifications or formal verification. These are some of the companies or some of the prominent companies in the VLSI design area. Intel Corporation, Texas Instruments, Cadence Microchips Technology, ST Microelectronics, Cypress Semiconductor Technology, Cisco, ARM, NVIDIA, and Synopsys. In conclusion, VLSI design is an essential component of modern electronics. It has revolutionized the electronics industry by reducing the size of electronic devices and improving their functionality. The technology has evolved to produce more complex and efficient chips, and also, in comparison to separate elements, it uses less energy. It increases the cost effectiveness of the gadget, and also operating speed has increased as a result of better circuit performance, and also improved the reliability, and it also promotes reduction and user-less space. And these applications are diverse and ranging from computer to medical electronics itself. These are the references which I used in my seminar. Thank you.